Okay, time to do a new project here. Looks like we have a Philco I just picked up, AM All-American 5, and it looks like to be a model 47-204, and I can already tell, looks like they put the cover on backwards. It's had the power cord cut. It's pretty crunchy and brittle there. So I guess we'll get this apart and take a look at it. This is farm fresh, just how I picked it up. And we'll take it apart, have a look inside, and see what we got. Okay, got the back off. Looks a little bit crusty in there, but not too bad. We have a loop antenna in here and soldered on here. We will have to unsolder that and get it apart, and let's see how this looks inside under the chassis. Okay, so here's where we are right now. We got it apart, and as you can see, this machine has not been touched, so obviously it's going to need recapped and going to need cleaned. So I'm going to get the dial face off so it doesn't get damaged while I'm working on it. And I'm going to take these tubes out and test them and possibly clean up the chassis a little bit. And when we get some things cleaned up and taken apart, we'll be back here shortly. Okay, well, we got this thing apart and started taking some measurements, and almost all of the resistors are out of tolerance. And looking at how these capacitors are kind of puffed out here, definitely paper caps, they got to go. So looks like a pretty extensive restoration on this one, but that's what we like. So we're going to go ahead and clean up these terminal strips, get some of the big solder blobs off of them. I will then proceed with the resistors. I'll get those swapped out and then go ahead and hit the capacitors. So as soon as we get some of that done and we get some changes here, we'll be back on. Okay, we're back here. We got most of the way through recapping and re-resistoring, but I want to talk about something I ran into here that's kind of unique. It's this little guy right here. As you can see, maybe, it's a resonant capacitor. I've never run into one of these before, and when I look on the schematic, it actually shows it as a capacitor in series with a coil. And of course that stumped me a little bit because I looked online, I couldn't find anything about what these are or what to replace them with. So I went on and commented to another YouTuber by the name of Dennis Carter. Thank you, Dennis. He just basically texted back real quick and said just replace it with the regular 0.2 microfarad and it should work. So that's what I've done, and hopefully that'll take care of it. I'm now about ready to put in the power, and I'm going to switch it around. As you notice, this is the old style series strung, and they always switched the ground side instead of the hot side. I'm going to move this switch over to here, and then I'm going to put a polarized plug on so that the neutral will always go to the chassis side or to the low ground side. And once we get that all done, we'll come back again. So this is where we are so far. Okay, we're back. So I've repaired this. The little bracket for the bulb holder was snapped off on the old one, and I just so happened to have a spare, so I put that on there. Got the polarized power cord put on. I put a new grommet strain relief, and I switched around. I made sure that the wide blade, which is the neutral, is not going through the switch anymore. Rather, it is going to the common side or ground side, whatever you want to call it. I put a new safety cap across here. This is a safe across the line type cap. And I wired the hot side into the power switch. I brought that over to the rectifier tube. So we're all set to go, and I'm going to flip this around. I put the tubes back in, and we're going to plug this into the Variac and bring it up very slowly and see what kind of results we get. We'll be right back. Okay, let's back this out a little bit, and let's see if we can't just get the radio and the Variac all into the same scene here. And we'll start bringing things up slowly. So let's start out. Let's look at our amps. Okay, so far we're drawing a little bit of current, so it looks like our tubes filaments are all good. And we're not drawing excessive current so far, so it doesn't look like we have a short. Got about 60 volts on there. So let's give it a minute, see what happens. See if we're getting any filaments. Hard to tell. Don't see any on the 50L6, but that doesn't mean anything yet. Come up a little bit. Let's bring it up to about 85. Around 85, 90 volts usually you'll start to get some action. I am not seeing filaments. I have a bad tube. Not getting any filaments. Go all the way for broke here. Getting little jumps of current, which tells me I think we have a filament that's intermittent. Let's move some tubes around, see what we get right there. Or we may have a socket that's loose. Okay, I guess we'll shut it back down, and I guess we'll take another look at it here. We'll be right back. Okay, we're back. What I'm not sure of is if this little tester will test the Loctal type tubes, which we have. I think it will. This is just a basic emissions tube tester. You can pick them up at flea markets or online, very inexpensively used, that work pretty well. This one's been restored inside. It's a little dirty on the outside, but works really well. I have a good mutual conductance tester, but it's not worth taking out. You really don't need one unless you're going to be working on really high-end equipment. If you're just getting into this hobby, something like this is fine. It'll test for shorts, and it'll test for emissions. It'll check your filaments and make sure they light up. And really, that's all you need to be able to do for this kind of equipment, just to see if the tube is good or not. So let's go and let's test the tube and see what we get. I'm going to start out with this 35Y4. Okay. And if I go here in my book, we look up 35Y4. There it is. So we want to set our filament to filament F. Right there. We want to set type triangle. Socket number 4. Which is right here. There's your Loctal socket. So we can do it. Selector number 2. Sensitivity set to 35. And we're going to disregard number 4 and 8. That means when we're testing the pins for shorts, those ones will test as a short, but that really is not. So we're going to plug this in, turn it on, and see what we get. So the first thing we're going to do is go to shorts test. We're going to rotate the selector and look for a little indicator to light up. So that's number 4. We ignore that. Number 8, we ignore that. And we are getting a short on pin 7. So this tube is shorted. So right now, that's looking like we have us a bad tube here. And that's probably why our current meter was jumping in and out. So I'm going to shut this down right where we are. I'm going to go in my little parts box, my tube box, and see if I have a spare 35Y4, and we'll be right back. Well, we're at a little bit of an impasse here. This socket here, this is one of those Loctal type tubes, and they're notorious for having problems with the sockets. This socket is shot and is going to need replaced, so kind of going to put this one on hold until we can find some suitable replacement sockets. Other than that, we were able to get everything recapped. We were able to get everything tested out, all the bad components replaced, and we're ready to go as long as we can get the tube socket replaced. So we'll be back as soon as we get some parts.